We live in a world of constant change. The automotive industry is no exception. New players have entered the market and are redefining the rules of the game, disrupting traditional supplier ecosystems and challenging the status quo. My name is Joachim Joe Werner, and I've now been working with open source for well over 20 years. A long part of that journey was with SUSE. First as a user, then as a partner, and for over 17 years now in various project management and product management roles at SUSE. During that time, I've experienced how open source and Linux in particular have transformed industries as diverse as telecommunications, healthcare, or retail. Across all industries, products that used to be defined mainly by their tangible physical assets, their features, their hardware, are becoming experiences that are largely defined in software. The automotive industry is just the latest in a long list of industries that are going through this digital transformation. Cars that used to be judged by their horsepower, the number of cylinders, a V6 engine, a V8 engine, or even a V12 engine. So impressive. Those cars are now becoming mobile devices on wheels. When you watch reviews of new cars on YouTube, in particular the ones about EVs, electrical vehicles, you'll realize that horsepower or sleek design or premium interiors aren't the most important things that matter anymore. What reviewers ask is, how easy is it to find the next suitable charging station with a built-in navigation system? Is the infotainment system easy to use and snappy? Can I get new features via over-the-air updates? Does the car support plug and charge, where I don't have to use a credit card or charging app, but just plug the car into the charging station and everything else is magic? Or can I manage my car from my smartphone? Find out where I've parked it, or in winter, switch the heating on before I start my trip. All this is done in software. And if the software doesn't deliver a premium experience, good old solid engineering can't save the day. More than a third of the value of your next car will be defined through its software stack and through the ability to evolve that software stack over time to further improve the customer experience throughout the lifetime of the vehicle. These radical changes are driven by 4 trends in automotive. Next generation cars will be almost always connected to the internet. They will be fully or partially autonomous. Often they will be shared, like robotaxis. And most of them are using electric propulsion. However, a large part of that software stack that enables those features is just there to do the job. It doesn't really differentiate one car or one brand from the other. So the challenge the automotive manufacturers are facing is to ensure they can put their resources onto the software that matters most. And so rely on proven technology for the rest. This digital transformation away from a focus on metal and motors towards bits and bytes hits the automotive industry hard. To succeed, it needs to adapt. Traditional supplier relationships need to be reconsidered. Integrating software stacks across multiple suppliers is much more challenging than integrating well-specified mechanical or electrical parts from different vendors. Each update of the software stack has to go through a rigid and expensive verification phase to ensure high reliability of the system. In other words, car manufacturers face a real challenge. On the one hand, they need to introduce the latest technology features. On the other hand, they must spend considerable extra resources again and again to verify those new stacks. Many automotive manufacturers have perfected just-in-time production and efficient manufacturing processes over decades. Remember, the automotive industry basically invented the assembly line. Now they need to reinvent themselves, or in other words, innovate everywhere. They need to create the digital assembly lines of the future. These digital assembly lines mean developer paradigms and vendor relationships that have worked for years need to be simplified and streamlined, made more agile. To give you a simple example, when your car is always connected to the internet, as many modern cars are, you need to be prepared to deliver software updates to fix critical security flaws just as quickly as a mobile phone vendor or a vendor of network switches has to do. Traditional methods of deployment and development, where the car goes through a multi-year process of design, validation, and integration, don't work anymore. They are too slow. And remember, new players with new, much more agile approaches and experience with software-driven development of products have entered the market. And more are to come. To make all that happen, IT infrastructure needs to be modernized across the board. The automotive industry has to handle huge amounts of data these days, especially once we are talking about autonomous driving. Not just in the car, but also during development, when the neural networks are trained that make modern driver assist systems so impressive, and in the backend systems and clouds that support the driving experience with current map data, traffic data, location and status of charging stations, and so on. They also collect telemetry data from the whole fleet. Only if automotive manufacturers do their homework and adopt new, more agile approaches, including the use of open source software, just like other industries have done before. Only then can automakers accelerate innovation and not only keep up with the competition, but overtake them on the fast lane. The race has started. SUSE has been helping enterprises take that fast lane to success for almost 30 years now. As a matter of fact, many of the largest automotive vendors rely on SUSE. We were able to help those companies because we believe in the power of many. With open source software as the foundation of your critical infrastructure, you tap into the power of many. Open source projects like the Linux kernel innovate faster than any proprietary software company could. Every 8 to 10 weeks, a new kernel is released. Thousands of authors contribute. On average, there's a new code commit every 10 minutes. By embracing open source technology, car manufacturers can join the ranks of the leading industry players in the world and embrace this power of many. Open source also comes with no vendor lock-in. Depending on the phase of development, your in-house skills, and the support needs you have, you can pick the level of assistance that fits you best. Whatever your decision is, SUSE can offer you the support you need to make your open source journey a success. Standardization is vital for the long-term sustainability of industries because it removes fragmentation in the ecosystem, allows for interoperability between vendors, suppliers, and solutions. Yeah, and also only when standardization replaces expensive one-off developments, vendors can ultimately bring technology to the mass markets. Standardization brings costs down, while it also increases quality and reliability. It fosters competition in the supplier ecosystem, and it makes certification and homologation much easier. In open source, this standardization is usually customer-driven, as we call it. De facto standardization happens by jointly working on upstream projects, not by committee. The best projects win because they are used most. Well-run projects with a healthy ecosystem attract more contributors than less successful projects. It's a market of innovation and ideas where contributors and adoption are the currency. This is why Linux is everywhere these days, from mission-critical infrastructure like energy grids and telecommunications networks to mobile phones to even space flight. Linux helps with bringing satellites and astronauts safely to space. It runs on those satellites. And even more impressively, it helps bring down astronauts and reusable rockets back to Earth. Open source is now even driving Mars exploration. As a matter of fact, my own son, a student of computer science, just recently received a badge from the NASA Mars helicopter project on GitHub for his contribution to one of the open source projects that helped make that NASA project happen. That's the power of many. Or as Gartner has put it, open source is becoming the backbone for driving digital innovation. At a first glance, it may seem as if the automotive industry has learned that lesson. More than half a decade ago, the first automotive Linux projects were started mainly for in-car infotainment. These days, many modern cars run one or more Linux instances, and their software stack contains a lot of open source software in their embedded controllers as well. But to us at SUSE, that reminds us of the early days of open source in the data center, when developers would still download sources from the internet, compile their own kernels, web servers, and databases from scratch, often on Unix platforms that weren't fully compatible with each other. I mentioned at the beginning of this talk that I've been with Linux and later SUSE from those early days on. Back then, even our own colleagues in SUSE Consulting would cobble together open source solutions specifically for one project, every single one of them in his or her own opinionated way. Well, quick results mattered. And you could get quick results with Linux and open source, that's for sure. Supportability, maintaining those stacks for multiple years, that was an afterthought in those pioneering days. Well, much of the automotive industry and its ecosystem is still stuck in that mode. Embedded and automotive projects are highly hardware specific and handled as projects with little reusability between them. The mainstream IT industry soon learned to outgrow the early days of just make it work culture. It learned to standardize. Instead of reinventing wheels, they started to focus on what really matters, your application stack. And if you recall, that's exactly the challenge the automotive industry has as well. Being able to focus on that part of the software stack in the car and in the backends that really sets their products, their brand, apart from the competition. In the data center and in the cloud, running solid enterprise-hardened Linux distributions like SUSE Linux Enterprise Server on commodity server hardware that is certified to work with the operating system that you are using allows you to focus on where you can really create value, your software application stack. With multi-year support and maintenance and access to the whole world of open source software brought to you as a pre-built binary package by SUSE and its OpenSUSE community members, you can boost your productivity. In other words, we help you tame the power of many. Virtual machines and just recently container technology have further accelerated software innovation. Now, you and your suppliers can trust to known-to-work interfaces between the hardware and your software. If your container has worked on the developer's laptop or in the QA cloud, it will also work in production because it's the exact same container, exact same code. Whether you are running it in the cloud, on-premise, or at the edge of your infrastructure, doesn't really matter. The telecommunications industry was one of the first to fully embrace that paradigm. As part of a concept called network function virtualization, the industry has fundamentally changed the way network infrastructure is developed and deployed. For both landline and mobile services, proprietary hardware stacks with telecommunications-specific protocols are being replaced by easy-to-upgrade commodity hardware that runs software stacks as virtual machines or containers and utilizes well-established general-purpose network stacks that were originally developed for the data center. SUSE has brought those technologies to the data center and is now helping customers and partners with bringing them to the edge. Not just the telecommunications industry, but also healthcare, manufacturing, or retail, to only name a few. The beauty of this development is that you can now standardize your software development and deployment procedures across the whole value chain, from the edge to the core to the cloud. Together with our partner Electrobit, we are now bringing Enterprise Linux to the car. Just like SUSE is an experienced leader in open source software, Electrobit is a leader in automotive software. More than 100 million vehicles worldwide and over 1 billion devices run software developed by Electrobit. Electrobit is a wholly owned subsidiary of Continental, one of the largest automotive suppliers in the world. Together, we are bringing the best of two worlds to the automotive industry. On the one hand, automotive-grade quality management that will ultimately allow using Linux even as part of the most advanced driver assist systems. Combined with a proven approach to delivering open source software as maintainable and supportable, reusable products, not as one-off projects. Just like we've done for many retailers and manufacturers in the past, we are going to help car manufacturers with significant challenges like factory preloads, unattended remote updates, and managing large fleets of software deployments. And we won't stop with just Linux. We are ultimately going to bring containers and container management to the car. This is obviously where the technology from our colleagues that recently joined us as part of SUSE's acquisition of Rancher fits in. While it may still seem like a bit of a stretch today, we envision lightweight container orchestration stacks based on our K3s single binary Kubernetes distribution. Stacks that become aware of the capabilities of the underlying automotive hardware and thus can ensure that workloads are placed where they belong in a mixed criticality stack, performance cores, functional safety islands, and so on. Once you have achieved the separation between the operating system, the hardware, and your workloads, abstracting away the hardware Your containerized workloads can run anywhere, and you can start thinking of new features in the car as containerized vehicle functions. Functions that you can test in the cloud and deploy in the car. Just like a modern mobile phone is basically a sensor suite and a compute platform that can be turned into many things by an application, an app. You know, a camera, a health tracker, a musical instrument, or a measurement tool. Now, your software engineers or third parties can do the same in the car. They can recombine existing sensors and actuators, and they can provide new software-defined features in the car, from theft protection to park assist systems, or new levels of autonomous driving. And just like the software that's driving modern web applications, those new features can be developed and tested in the cloud. In fact, many of those features may even require assistance from actual cloud services like navigation map backends or telemetry infrastructure. And you can develop both the front end that goes into the car and the back end that will be running in the cloud or on your data center with the same familiar tools, with the same test frameworks and continuous integration platforms. Now, what makes the SUSE approach so different? First and foremost, we think of our Linux and infrastructure offerings as open source products. Products that need to be supportable, not projects. Products that can be maintained for well over a decade. This means that in most cases we can provide security updates without breaking certifications for the complete stack. We also support multiple hardware architectures with a single unified code base. So whether you choose Intel or AMD or ARM, maybe late in the game, you can be sure that the software stack is almost trivial to port from one platform to the other. We've also started to build tools that help embedded developers to keep their familiar cross-build workflows where they can develop software and create operating system images for their, let's say, ARM-based target systems on a Linux server or even a Windows or Mac PC on x86 64, for example. Our cross-build tools are being developed with the aim to be usable standalone, but also seamlessly integrate into existing centralized build systems like SUSE's own open build service when you grow into these larger ecosystems. When it comes to open source software, you can look at SUSE and the OpenSUSE community as a one-stop shop, where you can get binaries for thousands of open source projects that will work together, or all the world of open source in a box. And finally, SUSE has a proven track record in supporting customers with their most critical workloads for almost 30 years now. With our solid business performance, even in troubling times like these, we are here to stay. Let's recap. In embedded automotive software development, you compile the complete software stack in a do-it-yourself way, integrating components from different layers, like the hardware vendors' board support packs, is on you. And so is certifying the whole stack to meet regulatory compliance. SUSE's approach has always been different. SUSE invented the concept of enterprise Linux distributions and was the first to ship one. By the time the software binary gets installed on your car, it has gone through a unique multi-layer quality assurance process. It all starts with the open source projects themselves, or what we call upstream. Today's open source projects, while sometimes still led by enthusiasts, are far from amateur when it comes to ensuring the quality of their releases. Upstream open source projects usually benefit from automated test suites that run and check in time and later to make sure that every software release is solid. Our OpenSUSE community then picks the upstream software up and uses the automated open build system to build binary packages from it. With our unique build system, we can build binaries for multiple hardware architectures in a highly repeatable way from the exact same sources and track compatibility and software dependencies between those builds over time so that we know exactly what we have to rebuild. As part of the build process, upstream test suites are already run again in the build system itself. Those binary packages are then tested on their own before they are added to an OpenSUSE community release, which is tested again. On the OpenSUSE Tumbleweed rolling release, we release hundreds of package updates per week at a quality that is so high that many community members are using an OpenSUSE Tumbleweed system as their daily drivers for the daily work. For SUSE Linux Enterprise, our commercial offering, we pick those packages and harden them even further. Integration tests are run frequently throughout the complete development phase of a new enterprise release or service pack. And throughout the beta phase, many of our hardware and software vendors, software partners, run their own test suites for weeks. We then cherry pick binaries for the automotive code stream that we deliver to our partner Electrobit. Electrobit has a very similar setup to the one SUSE has. On Electrobit's own instance of the open build service, additional code can be integrated without having to rebuild the well-tested binaries that come from SUSE. And don't forget, by the time they are shipping, the kernel, the core C libraries, and the compiler suite have already been used for building thousands of packages in the build systems, from source, again and again. And this is the best endorsement of quality assurance. With SUSE and Electrobit, just like the hardware of the car goes through thousands of kilometers of test drives, the software stack does as well. SUSE brings the power of many, the power of open source, to the automotive industry. With a simplified and unified containerized software stack, car manufacturers can modernize their infrastructure and processes. That allows them to accelerate development and deployment of software throughout the whole stack, from the edge to the core to the cloud. And together with Electrobit, we bring Linux to the car. We help you with embracing and taming the power of many, so you can innovate faster and deliver experiences, not just means of transportation. Experiences that can be improved over time with a software update, just like your smartphone. Thanks for your attention.